Hey, so the question is, how can we have or detect the velocity of the vertex and release a particle from that vertex when the velocity is high enough? So we've got a little bit of a system here already kind of set up. We have a general system group where we store all the particles, and we do this. We also have the same system here as a dynamic set because we want to build this system in case we need to use it as a black box. So we always create things in a general kind of fashion. We're going to have a piece of source geo, which is going to be our source geo here, which is an animated plane, just using a noise modifier. Let's go ahead and create our birth rule. And inside here, there's different ways we could use layer to particle. We're going to use object to particle in this case. Pick this. I'll say, hey, you're going to be the source geo. Tracking is going to tell us how do we want the animation of the object to affect TP or vice versa. And we want the object to affect TP, so we're going to say object to particle. We're going to use instant shape. And we need to basically get some information about this particle. We need to know how many verts does it have, vertices. So let's come over here to the geometry. Sometimes this menu on the create panel is faster because it gives you access to the whole categories at once, whereas if you use the right click menu, you're going to have to just do one by one and navigate a bit. Anyway, we're going to use object to turn that particle into an object. Then we're going to use geom object to get information about that object, and this is going to tell us the number of vertices. Now we can go ahead then and use the generator position born to say, use a shot, and we could say, hey, how many verts are we going to create? This is one way to do it. We're going to go ahead and say pistol shot, let's say points, but watch what happens. And let's set points here to be a little bit brighter and use ticks. Okay, they're all born here at the origin, right? Because we're not using any position information yet. Let's also go ahead and set their lifespan to be really long, no speed, and set their alignment to direction to be have no variation. So what do we want to do? We want to read information about that surface, how many verts does it have, iterate over each vertex, find out its position, and feed that to the position born. So we're going to use an iterator, and let's say the count is actually going to be the number of verts. We're going to disconnect this shot, and we're going to actually say pistol shot per call. And the reason we do that is because iterator is going to be generating a lot of data all in one sample time step. It's going to generate boom, 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 boom. And every time that call, that data gets sent out, we want position born to say, hey, every time I get new data coming in, fire off a pistol shot. So this is going to allow us to create the number of verts based on the position. So for every position that comes in, position born is going to create a particle. But we do need one more piece of information in here. We need the geom vertex operator, which is going to allow us to say, hey, access the objects, access the vertex ID, which is going to be the iterator number coming from the number of verts. And that's going to output a whole bunch of information about the vertex. We just really need the position right now. But we do also probably need, well, we might need the on here. Let's find out. Let's go ahead and save our file. Boom, step forward. Hey, there it is. Great. And so we can see that there are particles on every vert, so we don't need, sometimes you need to offset this number. The first number coming out of iterator is going to be 0. Let's collapse this stuff so it's easier to read. Oops. Okay, so here we get our points, etc. Okay, now there's some other things that we're going to want to do just to be clean. We're going to want, let's go ahead and rename this. Let's call this source geo, and this is going to be our points. Now our points, every points particle who comes out, we want them to remember which surface they were born on, as well as with what vertex ID they were using. So it might seem a little extreme, but we're going to go ahead and create a new dynamic set in a memory called memKey or memTop or memControl or whatever you want to call it. I'm going to make a particle called, we'll call this parent particle, and then we're going to also store the ID. This will be my vertex ID. Oops. call this control. Now we're going to set up a memory here. In this particle, the points are going to be remembering the data, so they get connected to memory. We need to pull in these inputs so that we can access them. Say, hey, this is my parent particle. We need to remember that source geo. And then what is my vertex ID? Well, I can just use the same data. Well, here's the vertex ID. We could output that again, or we can just use the same number here. So we'll do that. Great, let's store that. So now let's clear write debug, turn debug on, write these two to debug. Step forward, we'll just cancel, but we can see that like for vertex ID, the data is going to be 172, and the parent particle is going to be 0. So this is working. Clear that. Okay, so now we need these particles to actually follow their that vertex ID. So what we can do is we can say, hey, to the points, and we're just going to go grab, rather than recreate this, we'll copy this, drop it back, say, hey, access this now as output data. We can keep these or remove them. I'll just remove them to be clean. Okay. And now, let's say, hey, first we'll try this. We'll try surface position. The particle who's doing the work is the points particle. The particle shape is going to be that parent particle. We can do face ID, but you see there's no vertex ID on this. That's too bad. It'd be nice if that was in there, but send an email to support@cebus.com and maybe they can add it for you. Be surprised how much work Cebus could do for you. They're very, very great company and very responsive. And so now we're gonna go back and basically grab our setup again. So let's go back. In this case, we're just gonna grab these three because we don't need to iterate through all of them. We already know which ID we want. So our particle is gonna be this. And actually we can just say this. Okay. Now one thing we'll do first, some of you will realize it's going to be incorrect, but we will just go ahead and say, hey, take that vertex ID position and set the points. The points are the one being affected, and they're just gonna, points are gonna update their position based on this vertex ID. Okay, so now it should, let's go ahead and save. It should go ahead and follow over time. Great. Now here's the problem. Go ahead and turn on Inspector. Inspector's accessed with the I key or Show Info Tooltip, actually is what it's called. This allows us to, oops, now we got Analyzer on. Come in here, here's IDO2, it tells us stuff about it. This is the points group. What's its velocity? Okay, you're going to notice even though the surface is moving, all of these have no speed, which is because we are simply setting their position here, which is not exactly what you want to do. What you want to do instead is a dynamics operation. You want to use bring to. The particle you want to affect is the points. The position that you want to bring to is going to be that same vertex position. Let's go ahead and remove that position there. Now we're going to use the old style, but in frames we'll say 0, so it's immediate. And now what will happen is that those particles are actually moving and heading towards following that position. And so you're going to see now that they have a speed 3, 22, blah blah blah. So let's do this. Let's go ahead and find out. Let's look at it like a speed colored chart of what's happening. Let's go ahead and save. I'll call this debug speed. Okay, so now let's say speeds, and I want to show the velocity, and we want to use a viewport color to say, hey, show the color for these points based on their velocity. And let's say the maximum, we have a high value of maybe 22 in here, 24. There's other ways you can actually build a system that will collect all the data from all the particles and show you the entire range. If you want that bad enough, go ahead and ask for it. We can show you how. Anyway, so now we come here and you can see the color happening. And this shows you where the speed is occurring and how much. There's other ways you can do this too, where you can actually store that highest speed value over the course of the animation. All kinds of things you can do. Thinking particles is super flexible, super fast, and it should be your go-to tool for getting stuff done. Alright, so something else we're going to do here is, simulation starting on 1001. This is standard film practice. Keep frame 1000, or the first frame of your scene open, so that there's no TP calculation. You'll thank me later. Anyway, let's do this. We don't need the speed right now. What we want to do is we need something to control these verts so that they know, hey, should I keep following this? So one of the things we're going to do is we're going to set a new memory variable. We'll call this follow. Now you need to, a lot of times you will need to initialize these values at the birth of the particle so that it knows right away what should I be doing, so the value is not undefined. If it's undefined, the system might not work correctly, and then you'll be debugging and have headaches, and that's not fun. So we're going to say follow should be turned on in the beginning. Then we'll come here and we'll say, hey, if my points follow value, let's put that on top here. If my follow is true, then do the bring to. Okay. So you can see what we've done is we just connect this boolean directly into the bring to. So as long as this follow is true, bring to's on will fire and it'll operate. Excellent. Let's go ahead and save. Remember to save very often in your files. Also, don't forget that you have a kind of bring to or an increment function. All right, here we go. Now we're going to do the release. Say, hey, points, get your velocity. If your velocity threshold, if your velocity is not your velocity, but actually your speed. What's the difference between velocity and speed? Velocity is a 0.3. It's a vector that measures the length of the displacement per sample in units per second. Basically, it's a vector. If you want the speed, you just feed it into a what's called a scalar or a float value. That's going to give you the actual speed value of it. Okay, and then what we want to do is we want to turn around and modify our follow variable. So we'll copy that so we don't have to recreate it. Drop it in here. I'll say, hey, when my velocity goes above, let's say 24, then I want this memory to fire and occur. And what's going to happen? The follow variable is going to go off, right? Now it's very important to know that, well, first let's see if it works, then we'll get into the complicated stuff. Oh, you can already see these guys, some of these falling off like that, right? So let's set this a little bit higher. Let's set this to 30. See if there's anything that goes above 30. Scrub it again just to make sure. Yeah, okay, so you got something going over 30 there. How about 40? Let's make this a little more fun. Turn off edit on the fly. And now any change that we make at any time during the simulation any change we make in the wiring is automatically going to cause TP to recalculate, right? So we come out here and we say, well, what if I want to make this threshold higher? Oh, okay, so the highest one is like 51.2. Okay, we'll decrease this a little bit. We'll get a few more. So then you could do some fun things, like you could tell this threshold 1 to decrease over time or over the course of the animation, so that as the animation goes on, the requirement for this velocity to let go is less. Hundreds of things you could do. It's wide open. Okay. Anyway, so we kind of accomplished that. We show how to have points follow on the surface, how to birth per vertex, how to store that vertex ID in the parent particle, and set an initial should I follow variable, And then we say, hey, read that data, and if my follow is true, read that parent particle, the vertex ID, and use the bring to, which is going to give us velocity for the follow, which is good. Also, if you needed to use alignment, you can totally do that. Totally easy. And okay, and so then you'll have the release. The release just says, hey, as soon as my velocity value goes above this, make sure you don't have this inside checked, because then it's going to has to be inside that. That's how that works. You can read that in the manual. It's very clear. Mostly more clear if you play with it. Anyway, and then this will set the follow variable to false, and then your follow will stop working. So that is the gist of it. Let's go ahead and save this file and we'll send it over. Hope you enjoyed, and you take it easy.